All doing well this morning. This is the part one of the Redesigning Mathematics webinar that we'll be hosting in support of our My Start to Finish project. Some of you would probably be expecting to see Jenny Schenker hosting this webinar, but Jenny was called to another meeting where she's representing us in some national guided pathways work. So she will be joining you next week in part two of this webinar. So you have me today. I'm also joined by my two colleagues, Precious Miller and Katie Girardello, who the four of us make up the team at the Michigan Center for Student Success. So I just want to go over a few housekeeping items before we turn it over to the Dana Center. The first thing is to please rename yourself to include the name of your college beside, like I have done here in the example where I've renamed myself to include MCCA. And so if you go over to your system tray, click on participants, and then you should see yourself, if you hover over your name and then click more, you will see a little button that says rename. You can rename yourself and include your institution. We plan to utilize the breakout rooms for institutions, for colleges, participants to break out by institution. So it's very helpful for you to rename yourself. We have a couple of ways that you can engage during the webinar today. We can use the chat feature. And so again, if you go down to your system tray, if you're unfamiliar with Zoom, you can go in there. Typically, you need to click more and then go in there and open up the chat. And then again, back in your participant pane, when you open that up, you should see an option to raise your hand. And then you can raise your hand and lower your hand as well. So if you do want to ask a question, sometimes it's easiest to be able to raise your hand, and then we can pause and be able to respond to those questions or comments. So that's how we'll use our engagement today. I want to point you to a new project that we're working on at the Center for Student Success. We have become active Twitter users. And by we, I mean, I'm the weakest link in the Twitter work that we do at the Center for Student Success, but Jenny and Katie and Precious have been doing a great job trying to engage with faculty and staff at community colleges in Michigan on Twitter. So you can go to follow us on Twitter at MCCACSS. And you can use our hashtag, which we use on most of our work for My Student Success to keep the conversation going. And we have several other hashtags that we're using, including the My Start to Finish to track activity in our initiatives. So please join us on Twitter if you're a Twitter user. I'm happy to say that we had our first successful tweet chat today at noon. Where we talked about, you'll all be very pleased that we talked about math today. We talked about transfer, and we also talked about guided pathways today. So follow us on there. I think in this virtual world where we're all kind of connecting remotely, we thought it would be really helpful to share on Twitter. Today, super impressed with a lot of the tweets that were shared by through the Mishmatic Twitter. And just really fantastic work that's going on in math at community colleges across Michigan. So be sure to check us out. And also thanks to the Dana Center for joining us today as well. It was really fun to talk about math on Twitter. So you can, we've provided a link here to the MCSS initiatives and resources where you can learn more about our Twitter campaign. Like I said, we did our first Twitter today, and then we have 2 more coming up at the end of July and at the end of August as well. The slides that we have today are also available on our MCCA website. easy for me to say. If you go out to www.mcca.org and click on events up in the top, you'll be able to see all of the events hosted by MCCA. And then you'll see the Co-Rec Math Part 1. If you click on there, you'll see the slides that I'm showing you now, and then the slides that Connie and Paula will be showing you from the Dana Center on there as well. I know it can be challenging sometimes to view those slides on somebody else's screen. So please look at that. And then please remember to register for the part 2 if you haven't done so already. Part 2 of the My Start to Finish Designing Co-Rec Math, which will be a week from today. And then also the My Start to Finish Faculty Roundtable, which will be on July 14th. So please go out and register for those, and we'll look forward to seeing you there. We always want to include our contact information if you want to get in touch with any of us. And so that information is available on our slide deck. And then with that, I want to turn it over to my colleagues at the Dana Center. So I am going to stop sharing and welcome Connie Richardson and Paula Talley from the Dana Center at UT Austin, who we are grateful for you joining us on our Twitter chat and with us this afternoon. So I'll turn it over to you.
Thank you, Erica. Hi, everybody. Let me get ready to share. This is strange. Here it goes. All right. Okay, and let me see if I can get to the point where I can move everything around a little bit and still see the chat. Okay. All right. So welcome everybody, and thanks Erica. And I'm Connie Richardson, and I've met some of you in the past. And my colleague Paula Talley is sort of my support system today. She'll help me with breakout groups and monitoring the chat and that sort of thing. And then I'm going to focus on math pathways and co-requisite supports and the latest research on those. I know that many of you have attended workshops and conferences about these topics. You've done work on your campus to various levels, and we're going to kind of gauge what that is a little bit later, so that we kind of know where to start and where to head from. And so what I want to do is really focus on what's the latest thing, and then backfill if there's any kind of background knowledge that anybody needs us to fill in on. So in the upper right hand corner, you'll see that there's a tiny URL with some resources. If you want to take a picture of that real quick with your phone, that link will pop up again on some additional slides later. So if you don't get it now, you'll get a chance later to see that link. And Erica, feel free, anything that's in that box folder, feel free to move it over to your box folder as well. That's perfectly fine. We want people to have access to it and make use of it. And at the end, we'll have our emails, mine and Paula's, and if there's any questions that pop up about additional resources, we can shoot those over to Erica and Jenny to drop into your folder as well. So let's see. Can't find my cursor. Yeah, sorry folks. There it goes. And so we've already talked about tech norms a little bit. I just would say that we are going to go into breakouts. And so even if you are hiding your, if you have your video off right now, if you can start your video when you're in the breakout groups, then that really helps with the conversation flow. And so let's see. I just want to pop up our group norms that we use, and really I want to focus on a few of them. I'll give you a minute quietly. So just to pick out a few, one is make equity central. So any of the work we do, and that includes any of the redesign work that we do, we have the best of intentions, but if we're not keeping equity central and inspecting for it all the time, we can actually have inequitable impact with our reforms. And we'll talk about that a little bit later, a little more in depth. So we can't just assume that something that sounds like a good idea is actually going to help close equity gaps. They could actually increase equity gaps. Kind of in the middle there, seek clarification in language and ideas. So if I do throw around some jargon or maybe an acronym or something, be sure and let me know. Or, chat it and Paula can respond. And then finally, down toward the bottom, the bottom three is really when you're in your breakout groups, just make sure that everybody's voice gets heard, and be sure and encourage people to speak if they're not speaking up. Just a little bit about the Dana Center is that we do work across K-12 and higher ed. We also have an early childhood literacy program, but most of our work is around ensuring access to high quality math and science education and making sure that the math and science that students get is relevant to their post-secondary aspirations and their career aspirations. And we strive to work at the systemic level. And so in this case, those of you that are joining as part of an institutional team, that's wonderful. And that's how we'll be going into breakouts, so that you can think about not just you and your classroom practice, but how the institution works toward equitable access for students. If you're not here with an institutional team, if you are a singleton from your campus, then Paula will group up the singletons so that you do have somebody to bounce ideas off of. Our higher ed work, this is the vision for our higher ed work, which centers around math pathways. So I'm going to give you just a minute to think about that. The first 2 points of our vision are really our focus today, thinking about aligning math pathways to be relevant to students' careers and personal lives, and then the co-requisite piece, which is enabling students to make timely progress toward completion of their degree. And in the next webinar, Paula is really going to focus on course design, and part of course design is that supporting and empowering students to become better mathematical learners, and also links back up to the first point, which is being about prepared to use their quantitative reasoning skills. And so 1 and 2 today, 1 and 3 in the next webinar with Paula. And there's that tiny URL again, if you didn't get it before and you want to grab a picture of it now. The first, our workshop outcomes, at the beginning, we want to assess our current state related to math pathways and co-requisite supports. I have a rather extensive slide deck, not because I want to talk nonstop for 2 hours, but because I want to see where you are, and then I'll be able to branch off to different parts of the slide deck. We want to interact with the latest research and some promising practices from the field. And then we always want to think about, as we do these things and we pause occasionally to reflect, think about what specific action steps are, keeping in mind that equity lens, and planning at the beginning for what are we going to do, and then building in the continuous improvement process as we go. And then making sure that you have access to the resources that you need, and getting those to you, making sure that they're clear. So first thing we're going to do, we're going to go right into a breakout of assessing current state. Well, I guess even if you're from the same institution, you may not necessarily know each other if you're actually joining from different departments. So you might need to do some quick introductions. let's go ahead and say that the reporter for the group will be the person whose first name comes first in the alphabet. We'll need a timekeeper too. And so if that's the person whose first name comes last in the alphabet, the timekeeper, we're just going to have 5 minutes, and that actually goes pretty quickly. So the timekeeper will keep an eye on that time, and if you see that time is going by and not everyone in the group has been heard from, then the timekeeper can say, you know, this is where we are, and we still haven't heard from John. Okay, so the topic is that there are some possible descriptions of math pathways or co-requisites. So actually, I want you to talk about both math pathways and co-requisites, but think about them separately. And choose one of these descriptions, and you can expand on them or whatever. That, you know, you can modify the description, I guess is what I'm trying to say. So are you just now holding initial discussions? For example, maybe you're doing math pathways, but you're just now holding initial discussions about co-requisites, you know, that sort of thing. We have them, but we've still got a lot of students going through the traditional route. So we've got math pathways, but we've still got a ton of students that are taking the algebraic path. Or we've got co-requisites, but really it's only for the students that are real close to the cut score, and everybody else is still doing traditional developmental, okay? Or maybe you're further down the road and the majority of the students are in the right math course. And so maybe you're seeing that your quantitative reasoning or statistics pathways have grown and grown, and your algebraic path has shrunk to where really it's mostly students who are calculus intending at this point. And again, has your co-requisite been implemented to the point where you have very little prerequisite requirement anymore? Most of your students are in a co-requisite. So just want to kind of see where people are. Are we needing more information about getting started, or are we needing more information about scaling up and improving? Paula, are you ready?
Yes, and there's one large group I think I tried to match up as best as I could. So if you're mixed with a group that's not part of your institution, just get to know the folks that you're with since you're in this group for 5 minutes, and we'll figure it out.
Okay, then here we go.
And Erica, I didn't know if you and Precious or Michelle wanted to go in a separate room or...
No, we'll just hang out here with you. It's usually best if we stay out of the breakouts.
Okay. I don't know, can you actually see, oh, let me pause.
Including Michigan, that people are engaging in comprehensive redesign. And they're doing that work. I swear I lost my cursor again. They have common goals. When you look at the strategic planning for each of those states, they're all trying to increase access to post-secondary. They're all trying to increase enrollment. So not just that students apply, but then they show up. And not just that they show up, but that they complete. And we know that some of the ways that we can do that is we can increase the number of hours that students take per semester, because the longer they drag it out, then the less likelihood they are to complete. We can increase workforce readiness. That's something that systems are looking to do to make the time and money investment that students and society put into this education, something that results in workforce readiness. Increase affordability by reducing the total number of hours, so that students aren't taking hours that end up not counting, and ensuring transferability, that students, when they move from a 2-year to a 4-year, or across a like sector, or even reverse transfer from 4-year to 2-year, that their credits transfer and apply to their program. And along with that, to make sure that everything we do, that we are looking at data and providing evidence of the, first of all, effectiveness of what we're doing and the equitability of what we're doing. So that's common goals across systems that we see around the country. My start to finish. Michigan has had several initiatives. The Dana Center was heavily involved in the Math Pathways to Completion work. But the My Start to Finish is really focusing on this idea that there's a key indicator of finishing English and math in the first year, and the impact that that has on the likelihood that a student is going to successfully complete their program. And so, you know, getting a real fine point on what are we targeting. And so that's why we're here today. As part of this comprehensive redesign, so we've got these goals, and so Dana Center helps people tackle those goals by looking at these core elements. First and foremost, that we have aligned math pathways with default or recommended math requirements. We're going to talk about that a little bit, because based on some of the comments that you just dropped in the chat, it makes me think that maybe you've got aligned math pathways, but we might need to work on the default or recommended part. That you still have a lot of students that are taking that algebraic route when maybe they don't need to. A concern is, you know, students that haven't chosen a program yet, but then you can implement meta majors. Usually students can choose a meta major even if they can't identify a specific program yet. Multiple measures placement, to make sure that we do the best job we can in figuring out what the student's preparation is. A single measure placement, whatever it is, any single measure is not reliable, is not a good predictor for an individual student. And so using multiple measures placement, getting more information, is going to be a better predictor. So once you've implemented multiple measures and you realize, oh, wait, a whole bunch more students really are eligible to be directly into college ready, then we thought you put them directly into that college credit bearing course. And then you've got a reduced number of students that you need to really focus on. They've, like, every measure you've looked at them on deems that they're still probably underprepared. Then we can do enhanced advising with those students, because we have less of a load. And so we can pay a particular attention to those students and provide co-requisite supports for them. So that's the core elements that we would advocate for. So we're here today to talk about kind of what's the latest information about those initiatives. This just kind of puts them all in a graphic around student success with some additional information about each one. And so as we're going to focus on math pathways and co-requisites today, alignment to programs is something we're going to talk about. Relevant content, Paula will be talking about next time. Evidence-based curriculum and pedagogy, Paula will be talking about next time. Under the co-requisites, aligned content, that's going to be Paula. Embedded success strategies, we're going to talk about just-in-time supports here today. And we can touch on any of these others as well if you have questions, you know, want to drop a question in the chat or raise your hand or whatever. But just as we go through, just let me know if there's something you want to talk about. The intersection of math pathways and co-requisite supports, a lot of times they get talked about separately. And so many of you have probably seen this graphic before that shows some research from way back in 2014, 63,000 students that were referred to multiple levels of developmental ed, and how few of them came out the other end. So of those 63,000 students, something like maybe 6,500 of them came out the other end of the pipeline. And so you're looking at, 57,000 students that got lost somewhere along the way. If we can do something about that, then that's going to really impact that my start to finish, right? Like if we can get them to get their credit-bearing English and math in their first year, then a lot of those students will be able to go on and be successful. Particularly if you look at the top of this graphic where the arrows are going up, those are students who were passing and yet didn't come back the next semester. So when you look at just an individual pass rate of a course, that might look good, but what you don't know is how many of those students that passed your course and didn't re-enroll for whatever reason. And so there's definitely a lot of students out there that we are losing who are successful students, but this long sequence is getting in the way. So I just wanted to set that one up to say many of you have also probably seen the Tennessee Community College's co-requisite data from when they did their first full implementation year. The blue bars represent the prerequisite model back in 2012, 2013. The students' ACT scores are shown along the bottom. Every high school student in Tennessee takes the ACT, so that's why they use that as their data comparison. And the green is the results when they implemented co-recs. And so you can see all along the band of ACT scores, substantial increases in the number of students who were able to complete their credit-bearing course in the first year by doing co-requisites. I figure that since many of you are already doing co-requisites, you've already seen this, but I just wanted to remind you of it because it pops up again in just a minute in the latest research, okay? So if you do have questions about this, we can come back to it later. Just let me know, okay? I'm going to pause for questions in just a few minutes. Another piece of research that has gained a lot of prominence now, so I'm going to go back here. The Tennessee data has been questioned some because it was not like a research study, right? This was Tennessee had some institutions doing co-requisites. They were having a lot of success. Indiana was having a lot of success with co-requisites. The ALP model in English at Baltimore County was having a lot of success. And so Tennessee decided to scale up, and then they did pilots across the state, and then they went full scale across the state. So they didn't have a comparison group other than comparing back, several years prior. And there were multiple changes in the Tennessee system during that time. So a lot of people questioned those results. So City University of New York has this research study that was like a scientific research study where they did a randomized controlled trial. That was always the criticism of all the previous co-rec research was nobody's done a randomized controlled trial. So City University of New York took that on. I'm going to go through this pretty quick, so let me know if and I'll pause to see if there's questions about it. They took about 900 students. These were all students who were eligible to take statistics as their math credit, okay? And they randomly assigned them to either elementary algebra or directly into statistics, and they call their co-rec a workshop. So directly into statistics with a support workshop. And Yeah, I'll come back to that in just a minute. They were concerned that maybe, well, okay, that's changing two things. It's changing from algebraic content to statistics content, and it's adding a workshop. So we really ought to add this third group where they're doing algebraic content and have support. So we can kind of parse out, like, is there an effect because of statistics, and is there effect because of the workshop? So that's what they were looking at there. So those 900 students roughly evenly randomly assigned across those three groups. Now, the elementary algebra group on the left, well, and the middle group too, once they get through with elementary algebra, then they would go straight into statistics. So CUNY had already accelerated their pathways, okay? And so one or two people mentioned in the chat that they have accelerated their pathways, but not to co-requisites yet. And so that's what CUNY had done. In fact, that's how the Dana Center started out way back in the day, is we did an accelerated pathway. And so they said, if you're doing statistics, you don't have to do intermediate algebra. You can do elementary and then skip to statistics. So that's the path that the left two groups are on, okay? Alrighty, so they ran them through the semester. They had really rigorous controls. I encourage you to read the study if you have questions. Basically, they randomly, they assigned instructors as well, and the instructors were teaching each version, and the instructors didn't know exactly what was being looked at. So these are the success rates at the end of the semester. I'll give you a minute to look at those. And if we pause to think for a minute, then the left-hand side is students in elementary algebra, 39% success rate. The students in statistics with the workshop, 55.7% success rate. And so that is, students were way more likely to pass a college level course than a developmental course. And not only that, but the students in the first and second bars still have to take statistics. So we've only got 39 and almost 45% who have passed at this point, and they still have one more course to take, and the statistics students have completed their math requirements. So we can kind of see here the effect of the workshop, that the workshop gave a bump of about 5.5%, and then the effect of statistics is about, what is that, about 11%, almost 11%. That's obviously a very rough analysis, but you get the idea that as we were looking at the Tennessee data, I want to point out that Tennessee has about 64% of their students on average are in statistics each year. So they have a very strong statistics pathway. This study was around the statistics pathway. Indiana has had very strong results, and about half of their students are in the quantitative reasoning pathway. And so I had had kind of suspicions all along about whether it was the effect of pathways that really made the difference. And this slide really spoke to me about that the workshop helped, but the fact that students were in statistics apparently made a difference. So the question is, a comparison of all of CUNY's stat students was 55.7% below that average. I believe it was. I'd have to go back and look at the study. That's a great question. And I'll say in general, many of the reports that are coming out in the last couple of years are that actually the students who are in co-requisites are often outperforming the students that are not in the support course. And I mean, and it makes sense, right? If you're in class an extra, this was 2 hours a week. The workshop was 2 hours a week. If you're in class an extra 2 hours a week and you have your peers and you have an instructor, that you have a lot more opportunities for support, and that you could potentially be more successful than the students who are in some respects trying to go through the course on their own. I do think that CUNY's overall success rate was higher than 55.7%, but I'd have to go look that up to be 100% sure. And it just occurs to me, I don't think I dropped the CUNY study in the Dropbox, but I will. Okay, maybe Paula can find it and do that. Another question that comes up a lot about those CUNY students is, well, maybe you got the math credit, but they missed out on some algebra and it's going to impact them in the long run. They're not going to be able to pass their science courses. They're not going to be able to do well in business, for example. How do they do? And so the researchers have been following, I picture them stalking these students because they've really tracked them really extensively. And so we see what has happened with these students after 3 years. And just if you focus on the top row of the really dark boxes, that those elementary algebra students, 17.1% of them have graduated, but 25.2% of the statistics students have graduated. And if we look at that on a percentage basis, it's 8 percentage points greater, but 8 percentage points compared to 17 percentage points, that's 150% when you get up to 25.2%. So that's a 50% increase in the graduation rate. I don't know any administrator or faculty member who wouldn't be thrilled with a 50% increase in graduation rate. I will say that after 2 years, it was a bigger difference. The stat graduation rate was double the elementary algebra graduation rate. After 3 years, the students on the left-hand side have caught up some, and they may continue to catch up some as we continue to follow these students. They may continue to catch up, but meanwhile, they've spent more time in college, they've spent more money, that's more years that they haven't been out in their career earning that, professional wage. And so even if they do eventually catch up, they've still put in a lot more cost in a lot of ways, time and money. So looking at these two pieces, the Tennessee piece and the CUNY piece, I just wonder what questions you have. So I want to just pause for a minute for you to make some notes for yourself, and then we'll take some questions. Okay, so you can drop it in the chat or feel free to unmute.
So this is Ken Hinsman here from Bay College. I have a question. As far as the City University of New York study, do we know that they were doing an in-time type remediation in their workshops, or was there something else going on? Because when I was at Wayne State, we had, I don't know if anyone's familiar with Wayne State's prep program, but they do a workshop thing for basically basic algebra all the way through Calc 2. At least that's what it was when I was there. They didn't do a whole lot of in-time remediation. They did a whole lot of spoon-feeding exam and final exam problems during these workshops. And I also know that they coerced a lot of students to drop if they weren't showing signs of success early on. So, yeah.
Yeah, thanks, Ken. I would say that's a really good question, and this is why we really encourage everyone to work as a department, right? Like, I'm so glad that some of you are here with your departmental colleagues, that when you're working on this, you'll hear the same things from some of the people in Tennessee. They'll say, well, we were told we better get our success rates up, you know, that kind of thing. And so it is incumbent on you at your department to say, this is what is going to happen in these courses. For example, things like if we have a common final exam across all of our sections, students who are college ready, students who need support, if we have some sections that are just college ready students, whereas other sections are mixed, or some sections are only students who are needing support, you know, having a common final exam, talking about what the expectations are for how much exams count versus homework. It's incumbent on the people in the department to hold the line on rigor, right? Like, we would definitely not, you know, we are all mathematicians. Well, not everybody at the Dana Center is a mathematician, but those of us who work on this side of the work, we're all mathematicians, and we all firmly believe in mathematical rigor. We do not, the last thing we want is for students to get through, get a degree, and get out in the workforce and not be able to perform. And so the department has to work together to hold that line on rigor. And that's the response I have to that. That you can, there's CUNY has put out a series of reports. If you just Google Logue, L-O-G-U-E, and Watanabe Rose, let me go back to that. And Douglas, there's the citation that if you Google their names, then you'll, several reports, as they followed these students through the years, they continued to put out reports, and they're still working on those. And so in some of those reports, they really thoroughly kind of deconstruct what was happening in the workshops. Other thoughts?
And Connie, just to add a question there, part of the report, something very interesting, that they also do well in their science courses. You often hear thinking about the rigor of the courses and how they're doing. When they followed these students, they have to complete 2 science courses. And that's one of the questions that we hear. You're going to put them in a co-req, so they're not going to be prepared for their science courses. And their students did well on their science courses. And several of these students actually then transitioned into college algebra and other courses and performed very well.
Yeah, that's a great point, Paula. And I meant to say that and forgot, so thank you. So they were more likely to, they completed more science. And of course that, you know, the science professors don't know who was in these workshops, right? So these students, after they get through with their stat course, they're just all mixed together with the general student population. And they were more likely to do well than the students on the left. And they were more likely to switch into STEM. Now, so Paula was saying that they switched over into college algebra, et cetera. I do want to say that was a small number of students that did that, but it was more students on the right did that than the students on the left. They were more likely to switch over to a STEM program that required them to go through the algebraic path after they had already completed statistics. Okay, so if anything else pops up, go ahead and drop it in the chat and we'll come back to it. But as I said, I was starting to suspicion that maybe Pathways had a little bit more to do with this than just co-requisites. And so the Community College Research Center at Teachers College Columbia has done some extensive research on the Tennessee students, going back to those guys. This is some pretty nuanced research with a lot of levels of detail. So I'm gonna try to go through it quickly as we are, like almost an hour in now. But let me know if I go too quickly. So I want to give you a minute to read this and see what stands out to you. So this is why I put on the title slide the intersection of math pathways and co-requisites, that it's really how these work together with students being in a math course that is relevant and accelerating them so that they are making progress in their program. I'm going to talk about this more. This was just kind of like the high level takeaway, right? Something you need to know is the students that they studied in this report, because we're going to look at kind of two big pieces that come out of it, and we need to know who the students are that we're talking about. So College Ready, they were using a single measure at the time. So College Ready was an ACT of 19. And what they were doing was a regression discontinuity analysis right exactly around the 17-18 and the 19-20s. So students who were college ready and students who were barely below college ready. Oh, great. Okay, so there's a question about equity, and we will come back to that shortly. Thanks. So this sample of students who are right around the cut score is more than 1/3 of all students. And the reason that they do this right around the cut score is because it's been well documented in prior research that students right around the cut are very similar to each other. So a student that makes an 18 on the ACT and a student that makes a 19 on the ACT are basically indistinguishable from each other. The 19 is equally as likely to fail the course. The 18 is equally likely to pass the course, right? There's no difference between those students because these tests are simply not accurate enough. So one equity piece is that using a cut score like this, that using a single measure for placement is unreliable, and is more unreliable for students who've been marginalized in the past. And so that is students of color, students who are low income, students who are LGBTQ. These students that have been marginalized in the past and underserved in the past are even less well represented by a single test score. So that goes back to multiple measures, that multiple measures will definitely give you a better picture, and it will more accurately place your students, and it will definitely give you a better picture of your students who've been underserved in the past. So the reason I emphasize the fact that this is students just around the cut is that it's talking about that the students who placed in co-requisite have comparable outcomes in gateway courses to the students who were placed directly into college math, and also perform at least as well in subsequent courses. Well, they're basically the same students, right? Students that are that close together in cut are basically the same students. And so it's not really surprising at all that they performed as well. Okay. But something that I really want to point out that has been misinterpreted in the media is that it says other results reveal that co-rec remediation had no impact on enrollment, persistence, transfer, or completion when compared to no remediation or prerequisite. Okay. So we're like, wait a minute, that says that co-rec doesn't have any impact. Well, it's saying, remember, we're talking about students who are very close to the cut. We're comparing them to students who are just above the cut, and they're performing the same. And so those students who are really close to the cut, they have some negative effect by prerequisite. If you put them in a prerequisite, they're slightly less likely to not complete. And so putting them in a co-rec just basically kind of balances everything out. And so the data doesn't show like this huge co-rec bump. But that's because we're only looking at the students that are right around the cut. So when you think back to the CUNY study, the CUNY study was students who were way below the cut. Remember, those are students that they didn't place into the intermediate algebra level. They placed down in the elementary algebra level. They were way below the cut, and we do see the big impact from putting them directly into the co-rec. So this is really just kind of a cautionary tale about this CCRC study, is to realize when it's saying there's not much effect by co-rec, it's because we're looking at those students that are so near the cut score. Yeah, so that's what I was just going to come back to that. Okay. Oh, I forgot to change the title there. Okay. So I know one question or concern is about equity, and let me come back to, let me talk a little bit about math pathways in general first, before you go into breakout. And oh, so Paula has dropped in there that Tennessee did publish, thank you, Paula, I meant to say that and lost the thought. That they did study, they did disaggregate their data. And so you can find some research reports that show that it did work to, the co-requisites did work to close, to start to close equity gaps, okay? And as they scaled up, it closed them even more. So students who have been, as I said, students who have been marginalized in the past are more likely to not do as well on standardized exams. You can read a lot about the stereotype threat on standardized exams that leads those students to perform below their abilities. And so by bypassing developmental and putting them directly into college level and providing them support, then they were able to demonstrate their true abilities and be successful. And so you see that effect in the report that Paula dropped into the chat. And just in general, I will bring this up later, but you know, depending on what we get to, but I do want to say, just to be sure, and as you look at your pathways, you said that you've got some pathways, but you know, more students are in the STEM path, algebraic path, than the other paths, for example. Disaggregate that data and see whether your students' participation in the algebraic path is equivalent to their representation in your student body as a whole. Okay, so if you have if you look at, we have 40% students of color, but our algebraic path is only 20% students of color, then that's an issue. And students are, it's something to inspect, right? Why are the students of color not participating in the algebraic path? Similarly, with your co-requisites, those of you that have started co-requisites, I'm definitely going to get to this study in just a minute to be sure that you want to make sure that your students are equitably represented in your co-requisites. While you're in the process of scaling up your co-requisites, be sure that you are checking out whether students are equitably represented. Multiple measure placement. Let's see how much time we have. We can definitely talk about it. And we can definitely drop some resources in the Dropbox as well. But maybe we'll tell Jenny and Erica that maybe we can do another webinar at a later point about multiple measures if we do run out of time. Okay, so any other thoughts, questions, or concerns from the research discussion? We can go into breakout if you'd like, or we could just move on if you don't have other questions. Okay, we'll move on, and then and we'll see. We'll do a breakout later, and if you want to come back to the research, we can, right? If that comes up in your discussion later. All right. So anyway, what the Tennessee CCRC report tells us is that students need to be in the right math pathway for their program, and so. When we think about the intersection of math pathways, co-requisite supports, and course redesign, then really the prioritization is around the structures of math pathways and co-requisite supports. We definitely always want to pay attention to what's going on in the classes, but that the structures of having a math pathway where students are getting a math course that's relevant to their program, that's huge. And then secondarily, but also really important, is to accelerate those pathways, preferably all the way to a co-requisite model, where those students are able to get into that relevant math courses as soon as possible. And then you can work on your course redesign over time, but changing those structures has the biggest impact. Talking about piloting and looking at who's getting access to your co-requisites, not just who's getting access, but who's actually enrolling in, like not just that they have the opportunity, but that they actually enroll in the co-requisites. I want to look at some research that wasn't really about co-requisites, but it was about acceleration. So when people are piloting, there's some issues that we've identified. One is that sometimes they select models that are not scalable. So what I mean by that is that you might say, we're going to have the same instructor teach the support course and the credit-bearing course. And for some places that works great, and they can scale it up and they can serve all of their developmental students in that way. But other places, they don't have sufficient credentialed faculty for teaching the credit-bearing course to have them tied up in both credit-bearing and support. And so once they try to scale up, then they're like, we don't have enough faculty, we can't do this. And it's because they chose a model that they could not scale. Models that are not sustainable. Some places have 2 faculty members in the classroom with the co-rec students, but they're depending on grant funding perhaps to do that. And then when the grant funding runs out, then they can't sustain it anymore. So you want to think about models that you're going to be able to staff and sustain over time. But finally, the one we really want to focus on today is the equity issues. And so what I want to show you is that when you've got partial implementation, that there's a study that was on the Dana Center's own work. Like back in 2013, 2014, when we were first accelerating our math pathways in Texas. Then we went back and not we, Schutte and Keisler did some research on those students. And this is what they found. So I want to give you a minute to see what you notice about that. And if you want to just unmute and say, I noticed this, or I have a question about that. So the middle column is the students who were in the accelerated model, and the right-hand column is the students that were in traditional prerequisite, placed it like 2 levels below. Any observations?
White students are more likely to be in the accelerated option?
White students were more likely to be in the accelerated option. That's right. This was a randomized control trial. And so in theory, white students, Asian students, Black, Hispanic students should have been equally represented. Black students were slightly overrepresented. Hispanic students were way underrepresented. Other observations?
Female students were at a higher rate than in the regular.
Female students,
Family income.
And family income. That's what, like about $500 a month more, right? So students who had slightly more family wealth were more likely to be in the accelerated model. And so, like I said, this was a randomized controlled trial, but somehow in between the random assignment and students showing up in the class, white students were more likely to get in the class. And there could be a variety of reasons. If female students more likely to get into the accelerated, students with more family wealth. And so maybe the students said, no, I think I need to go slower, right? And so the students might have said that. Some of them might have said that. Some of them might have run into an advisor that said, well, looking at your record, maybe you should start back here and take your time, right? So there could be a variety of reasons, but the final, bottom line is that some students had more access than other students, and it needs to be inspected. So there was a question, did all students meet with an advisor or not? This was actually spread across 3 institutions around the state of Texas. And so, I doubt that we could say all of the students did anything, that there were different models at each of the institutions, different things happening. And so, institutional factors, family factors, lots of different things that need to be inspected. Really the bottom line is, as long as you're running 2 separate systems, you are always going to see this happen. Every time, it just bears out every time that whenever there's still this old pathway, these old structures, then there are always inequities. And so your best bet is to scale up as fast as you can And the other lesson learned there is not just go scale up as fast as you can, but be sure you're disaggregating your data all along the way, okay? So that if you are seeing, wow, you know, our Black students are getting access, but our Hispanic students, something's happening. We really need to do a focus group, a survey, you know, a variety of things to figure out why our Hispanic students are not getting access to this, even though they were assigned, they were told, here, this is what we want you to do, and it did not happen for some reason. So, and I'm not laying it on the student either. I want to be clear about that. That probably many factors, and we just don't know. So, summing it up, you know, the default or recommended math requirements. Be sure that the math that students are taking are aligned to their pathway, aligned to their program. Multiple measures placement. I'm glad to hear that y'all are interested in hearing more about that. So hopefully we'll get to that here in just a bit. And enhanced advising for students who are still underprepared, and getting them into a co-requisite so that we don't have that traditional developmental path sitting over there that they might get placed into. So I mentioned this already. Be sure that your students are equitably represented. So just who's in your pathways, who's in your co-recs, and then also looking at success rates and are they equitably successful. And look at your programs. This is actually college-wide, right? Like this is not just something in the math department. When you look at programs, are students that are your math pathways could have equitable representation, but then when you look, you see, oh wait, we've got some inequities in the students who are in the lower paying programs versus the students that are in the higher paying programs, right? Like, so when you're looking at who's in the RN program versus who's in the CNA program, so really looking at inspecting your programs as well, and inspecting your co-requisites, both for representation and success. Okay, I do want to talk about this issue a little bit about the math pathways, and I kind of already said about the structural change being important, and what we see, I'm going to skip on past this because y'all are obviously into math pathways, but maybe are just having trouble getting students into the right math pathway. So I can skip on over here. What we see in this slide, this is from the CBMS survey. Is it? Yeah, CBMS survey that comes out every 5 years. I'm anxious to see what the 2020 survey says. It'll be probably a year or two before it comes out. So if you look at the left-hand column, you see the distribution of students across courses, that more than half students were in college algebra or you know, pre-Cal 1 or whatever you call it. And over in 2015, that's gone down to 41%. So, and look at the numbers too. There's more students in college algebra, but it's just a lower percentage of the total. Stats has grown significantly, and that's great to see. Math for liberal arts, quantitative reasoning has grown a little bit, grown a lot in terms of numbers, just a little bit in terms of percentages. But really, when you look at the math that's required for programs, it's still a little bit out of whack, that there really should be more students in statistics and quantitative reasoning. And so you probably still have some students that are in the algebraic path that would be better served. They would get math that's better aligned with their program if they were in one of these other courses. And so what we kind of see is that a lot of people have implemented math pathways, but what it says, what their programs say is, you know, like, oh, you're going to be a nurse, then you can take any of these as your math course. And not only that, not only can you take any of them, but you can take it yeah, just whenever, you know. Maybe it's within the first 2 years. Maybe you have to take it before you get into the nursing program or whatever. And then for some students, actually, it's like, oh, you still got to do some prereq work before you're allowed into these. And so by signaling this to students, by having this as options, by saying, sure, you can take statistics if you want, then you're giving students options and they don't have the information that they need in order to make the best choice. And so you're signaling to them any math course works. That means that the math course doesn't really matter. And if it doesn't matter when I take it, it really doesn't matter. You're just asking them to check boxes on their degree plan, right? It's like, oh yeah, I completed that. I did my, if you still have PE credits, I did my PE credit. I did some fine arts. I did some math. That's signaling to students that math is not important. But if we can signal to students, this math is important, this particular course will help your program, you really need to take it in your first year and preferably your first semester, and then you're very specific about what math course it is, then you've sent them a different signal. Okay. And so, and if those right students are in the right course, then you can really tailor the course to serve the programs. So I want to, let's go into a breakout, and I'm going to give you a talking point for this, but if you want to talk about something else, feel free, okay? And my question is the student's math requirement an integral part of their overall preparation for their professional and personal lives? So, are the students getting the math they need for their program, for their career? Okay. And so when you think about whether you're having difficulty with getting students into the pathways, then that may help with answering that question. If you want to talk about something else, feel free, and we'll just take about 5 minutes. You ready, Paula? So Paula, can you just call on each group and ask what they talked about and if they have any questions?
Sure. Just going through the group, I know some folks didn't join, so forgive me if I call on somebody, but the first group is Andrea, Oscar, and Shanna.
So what did y'all talk about, or did you generate some questions?
And it looks like Shanna's trying to talk, but it's muted.
Well, technically, Andrea is our reporter. She's having issues with her microphone. Basically, we have some issues with getting things implemented. I'm trying to remember what the question was. Basically, the answer was no. We have some issues with transfer that other states don't have. Even though we have the MTA, if 75% of our students go to a school that requires college algebra or its equivalent and won't take math for liberal arts, then it does us no good to put students in that track.
Yes, that is definitely an issue. And so really, I said earlier, work as a department, but in some of these issues, it's really work as a region, right? You have to have your major transfer partners in the room and get them to sit down and hash out where, do they want to improve their success rates or not, basically. Okay. Paula, what's another group?
Emily, and Graham.
Okay.
I should say Emily squared.
What did y'all talk about?
I'm not sure which Emily you want. So we kind of Emily and I didn't talk about the actual question.
That's fine.
But what we did share, because we're actually at 2 different KCCs. I'm at Kirtland, she's at Kellogg. And so we were talking about some of the things that at Kirtland we had done last year, where we took our very basic math class and had a couple of sections where we pulled those people, and they were given the option, instead of taking that basic math, to take basic algebra. Still a developmental course, but knocked off that one.
Mm-hmm.
And they were very successful. So
Great.
that's what we were talking about.
Mm-hmm. Okay, great. All right, next group.
Janice, Jennifer, and Shanna.
I'm a Shauna.
Oh, Shauna, sorry.
No problem. Jennifer somehow didn't end up, Janice, we couldn't find Janice, but Jennifer and I spoke about the list that dealt with the students having a list of math classes to choose from, and how the student might not know or take the class that would help their overall educational goals. And we decided that we needed more time, and that we're going to have to continue that talk, because it was just too much for us to go over. The one anecdote that we left off on, though, was when I was a student and I was given a list of classes, it was what did I think was going to be easiest, or what fit into my schedule. It wasn't until I was like in graduate school where I started looking at the bigger picture of what class will help me do what it is I'm trying to do. So we said that that's going to require a little more discussion as to how we're going to maybe think about that.
That's such an excellent point. Thank you so much. One story that I often tell is, so there's this issue of, like what looks easiest, what fits in my schedule. And then there's also the issue of hidden prerequisites. Like my nephew's program, his degree plan said you can take you can take statistics or trigonometry, and he said he remembered that in high school I tried to get him to take statistics, and so he's like, I think I'll take statistics. And I said, well, no, you need to take trig, because you need physics, and physics has a trig prerequisite. And he goes, no, I can take either one. It says right here on my degree plan. And I said, no. If you look in the catalog, it says that you have a prerequisite on physics of trig. And so you can take statistics, but they're going to turn around and make you take trig. And he went and talked to his advisor, and his advisor told him, no, you can take either one of these. And finally, I sent him up the chain, and he found out that I was right. So, hidden prerequisites also an issue. I'm going to go ahead, because you mentioned this, I want to go ahead and talk about what are some solutions to this issue of students just taking the easiest class. So oftentimes, college algebra is often the lowest number college credit bearing course. And so it's the lowest number. It's got a name I recognize. I've been doing algebra all through high school. And so I'm going to do college algebra. And so what you can see is that you can list the recommended or required math course. So instead of saying all of these, you say QR is required or QR is recommended. And if a student transfers in college algebra, then you can say, oh, okay, we'll let you waive that requirement. You don't have to take another math class. We'll just we'll count your college algebra. But for students who are first time in college, they come in, tell them the course they should be taking. At some campuses, and UNT is one of them, but others are, they're saying, well, if you are STEM intending, then Calc 1 is your first core math course. And so anything before Calc 1 is not in the core. And so that way, when they're looking at, any core math, their choices are quantitative reasoning, statistics, and calculus. And then they're like, oh, okay, yeah, I'll do the quantitative reasoning. And then finally, another choice is give your QR and your stat the lower course numbers so that they look easier, instead of having college algebra being the lowest course number. And yes, so a lot of, Paula's put in the chat that a lot of places have renamed their college algebra course as pre-calculus, and for a couple of reasons. One, it signals this is intended preparation for calculus, and two, it gets it out of that, oh, algebra, I know that, I'll take that course. So it's got a couple of probably more nuanced impacts as well, but that's a couple of impacts of renaming your college algebra to say this is intending for calculus. Who's the next group, Paula?
Autumn, Jamie, Nicole, and Paige.
I'll go if that's okay. I don't know, for Autumn and Jamie, I'm not sure. Maybe they were in a different group. It was just Paige and me. And I'm going to jump in with a question, and it's about messaging. I would like some strategies for getting the academic advisors on board with that strong messaging about when and what to take for students for their math courses.
So I'm gonna throw some ideas at you, and then I'm gonna toss it to Paula. So I would say, first of all, what a lot of people try to do is just send some paperwork to advising, or an email or something like that. And I would say the advisors really need to be an integral part of these discussions, like particularly those of you that are just now kind of getting started on your co-requisite work. Make sure that your advising head is in every one of those discussions, that they're looking at that disaggregated data and they see the inequitable impacts, and they understand that this math pathway is the best for the students. The co-requisites are the best for students. Oftentimes, various people on campus message to students that college algebra or pre-cal is the safe choice because it will count for any program. But most places, their algebraic path, the success rates aren't that great, and particularly for students, if you could look into students' hearts and minds and know which ones really aren't going to end up being STEM majors, then they're even less likely to do well in that algebraic path because they don't see the need for it. They don't understand the rationale for why they have to take it. And that's not to say that student motivation is everything, but students have busy lives just like we do, and lots of stressors and pressures, and they have to make choices. And so when they can see, oh, I'm in this program class, I clearly see how this links to my career goals, and this is my algebra class, and I don't see at all how it links to my career goals. I have 2 hours to study tonight. Where am I going to spend my time? We're all going to make choices that seem to be most relevant, and students are going to do that as well. And so if we can get them into a pathway that truly is going to support their program, then they're going to prioritize that. And if the advisors understand that college algebra is really not the safe path because of that, then and they're in those discussions early, often, and disaggregating the data with them, then they're more likely to be on board.
Connie, I just wanted to jump in. This is Jenny, and
Mm-hmm.
I think what you're saying is, I mean, you're just so on point. I was like, wow, have you been at some of our meetings? Because I think it becomes very discouraging for faculty who are trying to promote these alternative pathways and to talk with disciplined faculty to then hear this argument, well, it doesn't, this is still safer and it won't matter, it won't hurt them to take this. And I think the more strategies that we can build to have that conversation so that it's collaborative and it's not, because I think it becomes very discouraging. Faculty get discouraged, and then it becomes sort of a self-perpetuating loop of why bother? Why bother to offer more sections of QR if
Mm-hmm.
students won't be in them?
Yeah. Yeah.
And can I add just a quick comment? I mean, I know something I've done, and I know many folks around the different institutions have done. Many times advisors have often themselves taken college algebra, so they think that's a safe course. So one of the things that you could do is take pieces of your curriculum, take example problems to them and have them look at the different problems and work through them, or at least read the different types of problems so they actually see the connection to the relevance of a statistics course to criminal justice or something like that, because many of them don't even have that understanding of what is in a quantitative reasoning or a statistics course. And as Connie stated, it's important to bring them in early on and often, and make sure you also reach that the message is being reached by you might have faculty advisors from different departments that don't know the initiatives that are going on, or you might have some part-time advisors that come in. So just like with the adjuncts, educating them, it's important to make sure you're reaching all of your advisors when you're trying to do this message. And I know it won't take any more time, but I know Michigan was doing some transfer work of bringing partner disciplines together. And I can't remember the four. I think one was biology, one was business, one was it psychology? What
Yes,
was
it was
from?
psychology, business, biology, and criminal justice.
I'm so happy I remembered that.
Good for you. That is awesome, Paula.
So, as those programs that work, that statewide work continues to move forward, and part of that process is hopefully selecting that math course. It'll help you to move your work forward with showing the importance of the math pathways in the programs of study.
Katie's asking if phases 2 and 3. Oh, Paula?
I'm just being difficult. My colleagues know, and they expect that, so I'm just teasing you.
Well, you're playing my role, Katie, because that's usually my job, is to give Paula a hard time.
A little levity after a long day.
Yeah. Okay. Paula, are there more groups? I've lost track.
You have 3 more groups. I think you had
you
had a couple people drop off, so some of the last groups are smaller now. But we have Michael and I think it's Rafiq. Forgive me if I said that wrong. One of you have any comments that you want to share? Oh, Katie, that's a good list. That's really going to push your math pathways work. Sorry, getting sidetracked.
Okay, do we want to move on?
Sure. Dorothy, Greg, and Katie.
Hello. So for the question in general, I think LCC is on a good path with communicating between the math folks and other pathway folks. There's always room for improvement. Todd Troutman from Mott felt that Mott was in a better place than it had been a few years ago. And Greg from Kirtland was, I would say, in the same vein, maybe a little less. Todd and I both have larger universities in our backyard, basically, that we have a large transfer population with. We also talked about basic transferability and how we worked with other institutions. Sorry, that's my kid. And how we work with other institutions for transferability. And LCC currently has a project we're working on with the Dana Center and MSU to back map our whole STEM path, math path. So we are working on it in various aspects, and we ran out of time from there.
Yeah, it's good to see you, Dorothy. I just saw your name on the list a few minutes ago. So
it's nice to see you too, Connie. How are things?
Good. Yeah, so Frank Savina, my colleague, our colleague, is working closely with Lansing on their path to calculus. So that's exciting work.
Frank and I have bonded over a deep love for Star Wars.
Yeah. Yeah, okay. That's how you know that Dorothy really knows Frank.
Last group was Andrew and Leah.
Okay. I was just going to say that when you get your math pathways aligned, it really opens the door for the opportunity to really work on that path to calculus, right? And just really gear it up to the best that it can be, because you've got the right students that are in there. Okay, so sorry, go ahead. Last group.
I think I was the last group with Andrew, I think.
Okay.
I'm going to turn my video on, sorry. We discussed that his school is basically in the beginning stages of it. I'm mostly work with science. What I know about our math is that we are utilizing pathways, but the co-requisites, I don't think so. And so, you know, I think a lot of students, from what data I do remember about our math, we are having trouble with students that get placed into developmental finishing through. It's like a clear problem.
Yeah,
so,
that's so, sorry.
I was just gonna say that perhaps Ken Williams would like to chime in on that. He might, most likely knows a lot more than I do about that. He joined late and he wasn't in our breakout session.
Okay. Ken?
I'll just say we've had, at OCC, we've had a lot of discussions about that. We haven't made a lot of headway, but we're starting to talk about trying certain things. And we have had quite an increase in our quantitative literacy courses. We're offering more of those. We have math literacy, and then we have a quantitative reasoning, and we developed kind of a non-STEM pathway brochure. So we're making small strides.
Okay, great. So there was the conversation about Wayne State program earlier, and then there was some conversation about that in the chat that happened. And so I want to say, you know, that when you're thinking about getting started, that the session that Paul is going to do next week on course design is really going to talk about things like, you know, structures that you can use, but also how do you make sure that you maintain rigor? What are some strategies for doing that? What are some strategies for transparency and making sure that everybody in the department is on board and behind the work and talking it up and contributing to its success rather than talking it down. So because I mean, it can go bad, it can go sideways, and not the least of which that you could have that inequitable placement or inequitable success. But as long as you are keeping your fingers on the pulse very carefully, then your whatever you do with co-requisites is going to be better than the throughput from a traditional developmental sequence. And then you can work to improve it over time. Any final thoughts, anybody, on this topic? If you do think of something, drop it in the chat. I'm gonna see what's next. So this is just some tools about how you can have conversations with your partner disciplines, and so this is in the Dropbox folder. Kind of like Paula was talking about with the advisors, you know, that having the advisors hear these discussions can be really valuable for them to see that you really are saying, we want students to get the math that they need, and go from there. So, all right, I'm going to skip this and just talk about real quickly about models that it really varies a lot depending on your student population and your institution. But I think maybe that we'll save some of this. I want to go ahead and just quickly say a little bit about multiple measures, because I'm not sure exactly what the questions are there, but since several people put in the chat that they were interested in multiple measures, if I don't address your question, if you'll drop it in the chat. But basically what people are doing, the most common multiple measure is to incorporate high school GPA. And usually we can drop some examples in the Dropbox of like a matrix that people are using, where like this side is, your standardized test scores, and along the top is GPA, high school GPA. And then it's like, well, if the test score is this, if the test score is high but the GPA is low, then we're going to put them in, we're going to give them the support course. We're going to put them into credit bearing, because I mean they scored high on the exam, but they may need some support because they did not have a high GPA, and maybe they lack study skills and things like that, or maybe they have a high GPA and a low test score. And so you say, we're going to give those students a support course. But if the GPA is high, then it usually, and you can set that, like when I say high, that's going to vary by institution and by region. But it's a number that you pick and you go, well, maybe it's a 3.5. If it's 3.5 and above, they go straight into credit bearing. They've demonstrated that they can persist over multiple years, multiple courses, multiple instructors. They have some skills. They have some academic skills. And so we're going to put them straight into a credit bearing course. And of course they would have tutoring available and things like that. But if it's, from a 2.5 to a 3.5, we're going to put them in a co-rec. If it's below a 2.5, then we're going to, go check out the test score and see what we think. Lots of different models for that. We can put some examples in the Dropbox folder. Some people are also doing things like some of the non-cognitive factors, measuring student persistence, that, there are some instruments around there. Also things like asking students what their outside commitments are. Are they caregivers? Are they working 40 hours a week? And those sorts of things, and saying, really, we think having some structured support would be beneficial to you, just to make sure that you don't crater the semester or something. So what kinds of questions do you have? Dorothy's asking, do you recommend a 2-point matrix? I think a 2-point matrix is an easy way to get started. It's very, you can make a super simple algorithm on this 2-point matrix, right? It's like, it can run itself. Once you start getting more sophisticated with doing some of the non-cognitive factors, you're having to give students assessments. And Jenny says a lot of research is showing GPA should be primary. And yes, we agree, GPA should be primary. And in fact, in a lot of places, they're not doing multiple measures anymore. They're doing single measure, but the single measure is GPA. Now, GPA is a higher predictor than test scores, but the two of them together are a little bit higher still. And so we would recommend that you use a combination of GPA and test score, but you weight the GPA heavier. And I would say that right now, as everybody switched to online and they're like, we don't have the capacity to make students do these placement exams, what are we going to do? A lot of institutions are just throwing them out. And saying, we're just going to go on high school GPA. And even, one thing we hear a lot is we don't get the students' academic records in time to use their GPA. But if you ask the students, they're pretty honest and on target to what their high school GPA was. If anything, they tend to underreport their high school GPA. And so even if you don't have that information, the official record from the high school yet, the student can usually tell you to a pretty good degree of accuracy. What other questions about multiple measures.
And I just real quick, I put in the Dropbox the AB 705 in California there, where they've done a lot of research around it. And one of the institutions that's been recognized for a lot of work that they do, Cuyamaca, their multiple measures is they look at high school GPA, and they also even pair that with math pathways. That's part of their intake form, is high school GPA and math pathways. So if you have a certain GPA, you know, you can go into you can place directly into the STEM. If you have a different GPA, then you could go into you know, quantitative reasoning or statistics. And depending on that GPA depends if you need the co-req support or not. So even pairing it with the pathways has been helpful for some.
Just a caution about that, though, is, you know, we want students to choose the pathway that matches their aspirations, right? We don't want them to choose a different pathway because it's easier to get into. So that's why, you know, it's really important to have the advisors in on those conversations, so that the advisors know that, you know, well, sure, you could go straight into quantitative reasoning with no co-req, but you told me that you really want to, you know, be in this field over here, which requires you to take calculus. And so it would be better for you to go into college algebra, even though it's going to require you to do a co-req, and you have to take more hours of math in that first semester, but it's what aligns with your aspirations. So, you know, some tricky messaging there that you have to watch out for.
Yeah, good point. They don't actually know like the differences. They actually have an algorithm where they put it into the system, where they put their pathways and put their different information. Then it pops out and says, you should take this course. So they don't know the difference of this is a longer or shorter path. It just kind of pops out and says, this is the default course you should actually take. Good point, Connie.
But there are people who do. If students have a lower score, they say, you go over into this pathway, and if you can be successful there, then we'll let you come back to the STEM path. And I just seriously disagree with that. And some places are doing it. I just want to make sure you're aware of this tool that we're kind of in the process of developing. Some of you have seen previous versions of it, but we've added to it. It's about co-reqs. It's in your Dropbox folder, and it's multiple pages. And at the end, I'm showing on the right-hand side there that we've got an FAQ that may answer some questions, but very, you know, more than willing to answer questions via email. And I hope we get a chance to talk about co-reqs more later. I cannot believe how fast 2 hours has gone. So I just want to say I am more than willing to stay on and talk. But these are our emails, and we're happy to answer questions that way as well. And I thank you all for coming. And I think we should kind of wrap it up in terms of we're at like 29 after. So thanks everybody. And I'm happy to hang on and chat.
Thanks, Connie and Paula. This was a great presentation. Thanks to all of you who are on this call, and look forward to seeing lots of you next week.